Hello, everyone, and welcome to Rodale Institute. I'm Gladys Zinati. I'm Director of Vegetable Systems Trial, and it gives me the pleasure today to share with you my webinar that it is about impact of management practices on colored potato crop nutrient quality and soil health. But before I start this webinar, I would just give you some points here. You can hear me, and if I'm not audible, make sure you click the audio settings on your screen. And for QA session, we will have it at the end of this webinar, and then we will have more questions, and please enter them in the QA button. For all other problems, please contact Maria Pope, the Education Director, and her phone number 610-683-1481. I just want to remind you all that this presentation is recorded and it is live now, and it will be posted on our website in a week from now. And to be more focused on the presentation, I would like to turn off my camera at this point, and we'll continue with the webinar. I like also to acknowledge my funders, mainly the Pennsylvania Department of Agriculture, the Wincott Foundation, the Johnny Seeds, the Pennsylvania Vegetable Grower Association, and the Pennsylvania Vegetable Marketing and Research Program, and the Orange County Community Foundation for their generous funding for the research I have been doing here. The outline of the presentation today, I will give you a background, a quick background about the experiments on potato. And I also would highlight some of the results that we have in hand, mainly on the potato and soil, and then give you a quick summary, and then we open the session for QA. So why potato? Because potato is a valuable crop, and it is not only important for consumers, but also for growers. And in US, potato production is about 1 million acres, and it provides a value of 4.6 billion. In Pennsylvania itself, the production is over 5,300 acres, and that provides a value of 18 million to our cash. Potato is very important because it is, for the consumer, it is a source of energy. And we know there are several crops that could give you energy, such as grains and rice and sweet corn, including the potato. But what is good about potato, that the energy that it gives you in the form of carbohydrate starch, it is about 1/4 of what you get from bread. So it is less energy, but it is valuable in nutrients as well. It is also good as a source of vitamin C and B6, but in vitamin C here, you could see that we always think vitamin C is coming from citrus, or it is coming from colored bell pepper, or it is from kiwi and banana. But in fact, if you look here, you will see potato is part of it. And so it is very good, especially when you boil it. And usually anywhere from 20 to 145 milligram for every 100 gram of potato, you will find that it can provide you one medium size of potato by 30% of what you need on a daily requirement of vitamin C. Just to mention here why vitamin C is also important, it is important because it helps in the iron absorption. And it is really important for all growth ages, not only the young and the babies, but also the females and males, and especially the pregnant women for their unborn babies yet for their fetus. Just to tell you that vitamin C is also important because it is water soluble. It is acting as antioxidant. And when it connects with other food, proteins, carbohydrates, and others, it stabilizes the free radicals that came out, and it also helps in healing the wounds that you have, and it continues to form the collagen, and it is also important for our immune system. Also, vitamin C is important for plants because vitamin C helps them against stresses such as drought, UV radiation, and ozone. And to continue with the potato benefits, health benefits, it is a source not only of the iron, zinc, calcium, and potassium, which in this case, the calcium is about 2 times the sweet corn, but also it provides you with trace minerals such as manganese, selenium, chromium, and molybdenum. And it is good as protein source, and it is greater than the protein source you get from sweet corn. But also it is really important to point out here that potatoes with their different colors, they can provide different sources and levels of carotenoids and anthocyanins. And we consider these as phytochemicals that provide or act as antioxidants and help the immune system. So anthocyanins is one of those flavonoids, and it acts as antioxidant, and it is usually you find it in blueberries and raspberries because of the bluish, reddish, orange color. And in the colored potato, if it is specially colored with the interior, the flesh, it is in this sweet potato as well, you will see the reddish or the purplish color of the tuber, and that's because of the anthocyanins in it. The advantage of anthocyanin when you consume food like that, it offers you the anti-inflammatory, it acts as antiviral, anti-cancer benefits also you can reap out of it at all stages, and especially against aging-related diseases. So there are really, really good benefits from eating and consuming potatoes. So with the health issues on the rise these days, it became very important to focus in my research work on the quality and the quantity of the nutrients in potato and other vegetables. And my research goals, just to give you a quick idea here. So in my research, I do look at how the cropping systems, such as organic or conventional, may impact also along with the management practices, which we will talk about it in a minute, how they impact the soil health, and consequently how that will impact not only the plant health and nutrient quality, but also the environmental health, and how we can link the soil health to nutrient health to human health. So this is the bigger picture of my research, and so how this potato experiments that I have been working on really fit into this whole big picture. So let's start here. So you will see the potato trials are on the vegetable systems trial, which is called VST. And for those who have not attended my last week webinar, it was about the vegetable systems trial updates. And I have a whole webinar about it and more details. So this is the vegetable systems trial. It is a snapshot of it. And we have in each of the blocks a conventional system as well as the organic system. And along the side of the vegetable systems trial, we have satellite experiments that are only organic in this case. And we planted in both of them potato. And the satellite experiment and the vegetable systems trial, we do, for example, vegetable systems trial, we do tillage with plastic, which you could see over here in both systems. And we do reduced tillage, which you could see here. It is sprayed with herbicide, but here organic, it is chisel plowed. Sorry, it is here, it is chisel plowed. In the satellite experiment, which is nearby, which any of the information we would like to test and feed into the vegetable systems trial, we combine these as systems here. So the satellite experiment, we have reduced tillage similar to what we have in the organic or the conventional, but in this case, it's only organic. But I included insectary strips, which you could see them over here on both sides of the system. So you can see them over here as well. So let's talk about tillage. In the vegetable systems trial, we have what we call full tillage. Usually we use the moldboard plow to plow the land. And then we put the plastic mulch and we plant the potato. In the VST, vegetable systems trial, we also have the reduced tillage. And here we use the chisel plow. And then you could see the difference between the two plows that we have. In the chisel plow, it is less aggressive. However, in the moldboard plow, you see that the soil has been turned upside down for that area where the plow went through the soil. So it is more aggressive with the moldboard plow. In the satellite experiment, we only conducted the reduced tillage, as I mentioned, and we have several varieties that we use there, which I will talk about in a minute. In the satellite, as I mentioned, I put insectary strips on both sides of the experiment, and they are compared to no insectary in every block over 4 blocks. So we can look into pests, predators, yield, and other nutrients. Mainly this is the photo of the full bloom insectary, and the insectary strip include several types of plants, a diverse suite of plants, because they really have different benefits of attracting natural predators, as well as they have different time of planting and flowering. And so to reap the best benefit of everything is to keep these types of plants that they attract the good insects. They provide them with a shelter, as well as they are really flowering and keep flowering because they come and take the nectar, and they can take anything that they need to populate there. You know that potatoes are always impacted with the Colorado potato beetle. And this is one of the stages. We call it stage 4, the larvae number 4, which is full before it goes into the ground and hibernate there before it comes as an adult. And so you could see here, this is a sting bug. The natural predator is feeding on the larvae by putting the stylet into the neck of that larvae. And so this is how we are using the insectary to improve the natural system to attack the pests that they attack the potato. Just want to let you know that I do not apply any pesticides on this experiment. So in the vegetable systems trial, we have 5 crops. And today we are going to talk about potato. And we are going to compare side by side a variety called Lehigh and the Purple Majesty, which is purple in the skin as well in the flesh. And in the satellite, we are going to work on 3 other varieties, including Purple Majesty as a common variety. So in the satellite, as I mentioned, the Purple Majesty, and the 2 other varieties is the Mountain Rose, which is pink on the skin and the flesh, and the Yolk Gold, which is a beige color from outside and yellowish in the inside, as you could see here in the photo. During the collection of data, I work on taking data on pests, diseases, yield, vegetable nutrient quality, density of minerals, phytochemicals, vitamin C and B6, and also on soil health parameters. But today we are not going to talk much about all of them due to the time we have and the results we have. I will talk about phytochemicals, and also I will talk about only vitamin C because we didn't have much of the data received yet from the laboratories that we have. So let's share some of the results that we have at hand, and I want to acknowledge at this point the results that we get from Dr. Lavanya Radivari. She's an assistant professor at Purdue University, and she is my co-PI on this project. And she has an equipped lab that can assess the phenolic acids, flavonoids, the anthocyanins, sugars, and you name it. And along with our collaborator, Dr. Radivari, we have Jen Halpan. She is a farm manager, a grower at the Dickinson College Farm. She conducted this past season in 2020 an experiment at her demonstration at her farm at Dickinson College, and we are still working on the data with her. Due to the situation we had during this past 6-7 months due to COVID-19, we haven't received much of the results from different labs because they were closed most of the time. And so I'm reporting here on potato for the vegetable systems trial. I'm going to talk about vitamin C, total anthocyanins, and total phenolic acids. And for the satellite, I will talk about total anthocyanins and total phenolics. I haven't got yet the vitamin C back. So let's talk about the results in VST, vitamin C and phytonutrients. And to start with, this is the vitamin C structure, the chemical structure. And on the x-axis, you will see two bars. One is the Lehigh with the conventional system, and this is the Lehigh with the organic system. When we compare the vitamin C concentration in Lehigh, whether it is grown in organic and conventional, we have not seen any significant difference. But that's okay because that's what our results is showing in 2019. We are repeating this in 2020, and then we will be compiling these results to see if there's any differences. When we look across Lehigh variety, but to see if the management practice makes any difference, such as the black plastic, which is represented by BP, and the reduced till by RT here, we also didn't see much differences. That's in the Lehigh tuber vitamin C. When we look at Purple Majesty, the other variety, again, conventional and organic, we did not see much of difference in the vitamin C. And when we look across tillage, black plastic and reduced tillage, also we did not see much significant differences. So now I put these two together, the Lehigh and the Purple Majesty, side by side, so you can have a better understanding of those. So the Lehigh organic, when we compare it to the Purple Majesty organic, definitely the Lehigh organic had much more vitamin C than the Purple Majesty in the organic system. When we looked at tillage itself, you could see that tillage really didn't make any difference in vitamin C concentration, irrespective of which variety that we have there. So for a summary for vitamin C, we see that organic Lehigh variety has more of vitamin C than the organic Purple Majesty, and tillage didn't have any impact on vitamin C. So let's now move on to anthocyanins and total phenolics. This is in the VST again, and on the x-axis, I listed here the anthocyanin in the tuber and the anthocyanin in the leaf. Now here you could see that I have a purple color bar, but you can't see the brownish yellowish bar, but you can see it in the leaf, which represents the lehigh. And on the y-axis is the total anthocyanins. And in fact, this is supposed to be milligram, not big M, sorry for that. And so it is the C3G, it is analyzed as cyanidine 3-glucoside. And so it is how many milligrams per gram of potato, dry weight potato. So let's look at the anthocyanins in the tuber. You could see that there is no significant difference in organic and conventional, so I didn't put it here because there is no way to make any differences, but I put this one to show you the difference in the tuber and the leaf, and you could see the anthocyanin, which is represented by that pigment of the purple color, it is much more in the Purple Majesty rather than into the lehigh variety. And you could see most of the benefit that you could get is from the tuber that you consume here. In fact, it is pretty very low in the leaf, whether it is in the lehigh or the anthocyanin, but we will see that more in the coming few slides. So here is the effect. We are gonna look how tillage will make any difference for the tuber itself in the anthocyanin. So when we look at lehigh and Purple Majesty, of course, lehigh doesn't have any anthocyanins, but if we look here into the Purple Majesty, we will see that the black plastic has much more than the reduced tillage. And they are significantly different. If we look at the leaf anthocyanins, we could see that there is no difference. All these numbers are really, really low. But I put this graph for you here to see that there is no significant difference among all these leaf we got from the either Purple Majesty or lehigh potato during the season. So a summary for anthocyanins, it shows that the Purple Majesty, when it is grown on black plastic, it has more anthocyanins than reduced till. And the lehigh tuber didn't have any anthocyanins because it's not purplish, it doesn't have that pigment, but no difference in the anthocyanin in the potato leaf across varieties or tillage. Let's look at the total phenolics, and let me tell you what is total phenolics here. Total phenolics is one of these compounds that's under the umbrella, what we call polyphenols. And so we have something called phenolic acids, and we have something called flavonoids, and anthocyanin is under the flavonoids. And so here is one of those categories under the polyphenols, we call it the phenolics. And in this graph, you see here, we have the tuber and along with it, the leaf. So you could see the total phenolics in the tuber, in the Purple Majesty, which is here in the purple, is much higher and significantly higher than the tuber in the lehigh. But the leaf, it's really important to look at because it has all these phenolics over there. It is in the lehigh, in the leaf more than in the Purple Majesty. So at this point, I want to point the tuber total phenolics and across the tillage systems. You could see here that we have Purple Majesty is really high in the tuber of these phenolics. It's about 5 milligram per gram, but it's still really good, between 5 and 5.5. And it is about 2 times, at least 2 times more than the Lehigh, whether it is black plastic or reduced till grown. And when we are looking at the leaf total phenolics, and we are looking here across the different tillage systems, there is no significant difference across the Lehigh varieties, but you could see that across the Purple Majesty, it is more than in the black plastic than in the reduced till. And in the reduced till Purple Majesty, it is the lowest across all the other treatments. To summarize, for total phenolics in the vegetable systems trial, again, the tuber has more of purple phenolics in the Purple Majesty variety than the Lehigh. And also on black plastic, Purple Majesty has more than the reduced till Purple Majesty of total phenolics. When we look at the leaf, we see that the Lehigh has more than the Purple Majesty, and also the black plastic Purple Majesty has more in the leaf than in the reduced till Purple Majesty. As far as the satellite experiment, which is all organic, and we are looking here at tuber anthocyanins. As I mentioned, we are using 3 varieties: Mountain Rose, Purple Majesty, and Yukon Gold, which is the yellow. And if we are looking at total anthocyanins in the 3 varieties, which is represented by C3G again, we see that Yukon Gold has nothing. No color of pigmentation of the anthocyanins. So it is about 0. It was not detected by the equipment, but you could see that Mountain Rose and Purple Majesty have very good amount of anthocyanins, but they are not significantly different from each other. And also I want to mention that the Insectary strips, with or without them, really didn't make any difference in the total anthocyanins. And so that's why I put the results here only by variety. But also I would like to mention that the range of tuber anthocyanins usually published between 0.25 and 0.48 milligram per 100 grams. And here it is per 100 grams, in fact. And it should say here that whatever amounts we were getting, it is within that published information. As far as the satellite tuber total phenolics, again, I'm showing you here there is no effect of Insectary or no Insectary on Mountain Rose or Purple Majesty or Yukon Gold. And so there is no effect of that treatment. So I pulled those data under the variety itself, and you could see that, again, they are all showing similar, although they show that purple has more, but statistically they are not different from each other. And they all have total phenolics that are really good amounts. Again, the summary for the satellite experiment for anthocyanin and total phenolics, it shows that for the anthocyanin, Mountain Rose was equal to Purple Majesty in the amounts of anthocyanin, but much more than Yukon Gold, which is in this case was about 0. And there was no effect of Insectary on anthocyanins. In the tuber, total phenolics, we found that there is no effect of Insectary or variety. As a summary, I could say, and I recommend that when you include in your food, in your diet, a collection and a diverse set of health benefits that you can reap from when you have several colored flesh potatoes. And then that you can get the anthocyanins, you can get the vitamin C, and you get total phenolics. These are all acting as antioxidants, and they can improve your health immune system. So now I'm gonna discuss the soil health in VST only in the potato plots. In 2019, we did a deep soil course, and we were looking into in the vegetable systems trial in each of the plots, in each of the crops that we grew, in each management and each system, we were looking into soil health indicators and assess them, in fact, at different levels. And we sectioned these scores 0 to 10, 10 to 20, 20 to 30, 30 to 60, 60 to 100. And in all of those, I'm gonna only talk about the 3 levels, depth, and when we assess them for physical properties, chemical properties, and biological properties. But today I'm gonna talk about total carbon, total nitrogen, the labile carbon, which is the accessible carbon for the microorganisms, and we call it the POC, and the organic matter in these systems. So let's start. And this is your surface, and these are with depth, and we took this soil course, and I'm gonna explain here the results of the percent nitrogen, carbon, organic matter, and epoxy as we go with those depths. And so first, I'm gonna talk about the percent nitrogen. And so the dark green, you will see in each level, in each depth, it is for the conventional, it's represented by C and V. And the light green, it is ORG, it represents the organic. And so you could see that the percent nitrogen in the soil in the organic system was much higher than in the conventional. And you could see the difference between them. It's more pronounced at the level between 20 centimeter to 30 centimeter. When we continue to look at the percent carbon, you could also see the same thing, that more of the carbon is in the soil under the organic system at each of the depths. And you could see that it is a huge difference when you go to the deeper level. Same with the organic matter, it followed the same structure. We have more of the organic than the conventional. And when we looked at the epoxy, which is the labile carbon, accessible carbon for the microorganisms, you could see that again, in the organic system is much more than the conventional, and it is the proportion, it's nearly the same when you go from organic to conventional at each depth. So I'm gonna talk more about the epoxy, and it is also a fraction of the soil organic matter. So this is the epoxy. This is the same numbers here. And this is a figure I took from Cornell. This is available at the website NRCS. And what they did, they compared the active carbon here, which is the epoxy labile carbon. They took all these numbers and they put the curve, the sigmoid curve, and they gave them scores. And so you could see anything in the red zone, it is not really good. Yellow is moderate, and the best score you get between 70 and 100 is in the green teal area. So let's look at those numbers and what we have here. So if we look at the conventional system at 2 depths here, you will see that they are over about this area here. So it is in the border of the green to yellow zone, about 70. When we look at the organic at the same depth, you could see that it is really at about 92, 93 score, which is really good. So you could see this is the system that has organic is really good in the active carbon to feed the microorganisms more than the area where you have the conventional. Then when we look at the deeper level, and we could see that these are in the area of the red zone, no matter whether it is organic or conventional. So it is very important where most of the growth of the plant is in the area of between 0 to 20 centimeters. Of course, there would be more deeper. They can go even all the way to 100. But major growth of the microorganisms, mostly it is in fact between 0 to 10 centimeters or 0 to 5 centimeters. But here I wanted to show you how well is the accessibility to microorganisms. So the overall summary for the presentation here, let's wrap it up and show you what we got. In fact, we didn't see any effect of system or either organic or conventional on the tuber nutrients that we discussed today. In fact, because it is early to decide. The experiments we have, it's less than 4 years old. And what is really important to help is that whenever we conduct these experiments on the vegetable systems trial, we are going to do it every year. And so with time, I could show over the multiple years how much of that nutrient is really changing with time. But really, it takes so much time and effort because everything needs to be collected, freeze-dried, should be ground, should be sent to different laboratories to get the different nutrients. So it takes time, but eventually, this is the goal that we can put all these different crops, and we want to see how these nutrients are changing with systems or with management practices. But if we look at vitamin C, we see that the organic Lehigh has much more of the vitamin C than the organic purple majesty, which is really good. So you can put in your diet more of the Lehigh. You can put even more of any of the colored potato that has a similar colors of the, what you call it, the yellowish. I wish that I had data for vitamin C to show you in the yolk and gold that I did in the satellite experiment, but we did not receive these data as yet. And so in the next time when I make more data and collect more samples, I'm gonna put all these so you could see that yolk and gold as well and the Lehigh, they will provide you with vitamin C. However, Purple Majesty is going to provide you with a total anthocyanins, which acting as an antioxidant, which is great in that case. And so you could see in this experiment, we find that's based on 1 year experiment. So we are going to continue doing that. In the black plastic, it was more than the reduced, statistically different, but it's really not statistically too much different. So, but these are the results that we got in 2019. But also, as a whole, in the Purple Majesty, we find more than the Lehigh. As far as total phenolics, phenolic acids, they were at least 2 times greater in the Purple Majesty than the Lehigh. And so what it tells me about all these nutrients, that it is really that if we include the varieties, we include different colors, different diverse of nutrients that we consume, they will really act and help our immune system pretty well. As far as soil health, I could say that all organic systems at all the depths that we analyze, between 0 to 10, 10 to 20, 20 to 30, we find them all are greater than these soil analyzed for percent nitrogen, carbon, organic matter, and labile carbon in the conventional system. And with that, I would thank you so much for being with me today on the webinar and attending and registering for this webinar and other webinars. And I always like to invite you to check other webinars that we have on our website. And if you go to rodaleinstitute.org, education webinars, you can find a big list of webinars. And if you are looking for one of the webinars that you don't see, go to the search box and put something that you want to know, and it will show you the webinar there. Or you can go by name and you can check webinars and the name of the person. This webinar is recorded and it will be posted within a week from now. And for contacting me, this is my email, this is my phone number, my mailing address. And now I'm gonna open the session for Q&A, and I'm gonna look now at the QA session questions here. All right. David Greenwood Sanchez is saying, hi, I'm wondering, will this event be available to watch here in the future? Yes, it would be available. Another question from David Greenwood. I read once that the color was quite common in early varieties of potato, but that the color was seen as undesirable and bred out over time to produce the whiter flesh varieties that are more common today. Is there any evidence for this idea? It depends, David, on the purpose and the, what you call it, the end result of using the potato. A long time ago, naturally, there are all types of colors, but when the industry wants to do something like potato chips, or they want to do certain cooking, they were selecting, as you are saying, more of the lighter colors. But in the past 5-7 years, we have seen that more people have been becoming more aware about the nutrients and their importance. And more research became showing the different nutrients and availability of things. So now you could see in the market, there are chips that are colored and they are purple, but they are limited. So the idea, yes, they were bred at some point, but now they are breeding and they are bringing even more the varieties that they have been already available and making more tests on them. Another question from David, and finally, are anthocyanins equally prevalent in purple potatoes and red potatoes, or other colored flesh potatoes? Does the color itself matter? Again, the anthocyanins, it has a range of colors. It can be from the orangey, reddish, dark and light red, bluish, purplish. And so you can find it in blueberries, you can find it in strawberries, you can find it in raspberries and in other potatoes, like I mentioned, even sweet potato. But the anthocyanin is a range of colors, and so equally prevalent in purple and in red, as we saw in the mountain rose. but they are at different levels. The darker, it's supposed to be more of the anthocyanin. If the skin is only purplish or reddish, but the inside is yellowish or whitish, you won't find much of that anthocyanin. So the best thing is that when the flesh and the skin are really full of those colors. Because most of the people are really peeling, but in fact, if you just boil it without peeling and eat the skin, if it is soft, it is really digestible, and you can reap both of them. And I have another question now from Scott Howard. As the vegetable tests are annual, are the potato fields in a rotation? Yes, they are in rotation. And we use the same cover crops every year that we use for the organic, and the same cover crops that we use for the conventional. We do the same treatments, and they are in rotation. Does the deep soil testing occur before the planting or after the harvest? That's a good question, Scott. In this one, we did it after the harvest of all the crops, and we took the soil samples in the fall. I'm gonna look, for some reason, somebody put probably a question there, but let me check in the chat area. Okay, let me see here. Oops. In the chat area, I have a question from Sarah and Michael Jones. How many years had this organic field been organic? How many years out of potatoes? The satellite experiment, it has been organic for over 25 years. The vegetable systems trial, it has been over 25 years organic, and then when it started in 2016, that's when we start the conventional versus the organic. How many years out of potatoes? They are really out of potatoes at least 3 growing seasons. A question from Kurt Ginter. Hi, could you explain the differences in the conventional organic practices that are being used in the plots? Yes, but I can tell you, Kurt, that if you go to my previous webinar that is posted now on the web, that it is about vegetable systems trial updates of the 3rd season and the 4th season, one in 2019 and last week. I talked in details about them, but in brief, what we do is that the organic system, we plant cover crops that before we put the potato there, and we plant them in the fall in Pennsylvania. And these cover crops include rye and hairy vetch, because we want to reap the benefits of the nitrogen that comes from the organic system. In the conventional system, we put only rye. And so that's the system that we use for the conventional. In the conventional, we also apply herbicides. In the organic, we don't apply herbicides. In the organic, we do the black plastic and the chisel plow for the reduced tillage. We do the same thing for the conventional. The same crop rotation, we do the same. The only addition that we do in the organic as a feeding system is we put compost every 3 years on that plot. That when we are rotating, we put compost to make use of the nitrogen. As I said, if you would like more information, you can go back to those webinars that I expressed in depth about them. But also you can send me email if you would like to know more specifics. Okay, Dave is asking, the levels of anthocyanin in potatoes is dependent on the variety. Dark flesh color is not perfectly correlated with the levels of anthocyanins. There are several factors that may affect what would be the correlation. And like we found that the mountain rose, we thought it is really anthocyanin less than Purple Majesty, but in this experiment we find them similar. So we previously did an experiment on these varieties, and it showed that Purple Majesty had more than Mountain Rose. So I could say it is variable, and variability depends on the weather, and it depends on the system and the time that because the climate has a lot to do with it, and you know, potato is underground, and how much of the impact of the pest on them. And who else? These are most of the questions I have here. I'm just trying to look through it again. And Gareth from Ireland saying hi to everyone. Hi, Gareth. I hope that you enjoyed this presentation. And we have more people from Pennsylvania. Yes, that's nice. And another comment from Miss Lulu. It is saying it's interesting to see such details on nutrition. Thank you for sharing these findings with us. It's a great pleasure for everyone. And I hope that this webinar made a difference in your life to eat better, to include different varieties in your diet, and see how much potatoes are really good when we eat them, and especially in this era of having COVID-19, and the immune system really is important. It provides you with vitamin C, it provides you with total phenolics and anthocyanins, and all these are acting as antioxidants. And with that, I really want to thank you all. I don't see any other questions. And till then, we'll see you next year. I will have more webinars coming. And during the winter, I will have Facebook Lives. I will take them during the things I'm doing in the processing things in the lab with my technician. But until next year, I hope everyone stays healthy and happy and eat well. Thank you, David. Thank you all for your kind words. Goodbye.